Good afternoon, friends. Today we'll see dip and strike problems, which is a part of engineering geology lab for the 4th semester students. In this, we'll be discussing about how to solve this problem, what is mean by dip and strike, and what are the application part of this. Before we start, let us understand the difference between dip and strike, or the meaning of dip and strike. Strike line is a line which is formed by the intersection of the beds or other planar features and the horizontal plane. So now you can say a line on the horizontal plane is called as a strike line. The next important part, that is dip, is now any bed or any rocks which makes an angle, or which makes the angle with a strike line, are called as a dip. So dip is an acute angle that a rock surface makes with the horizontal plane. That horizontal plane is the strike line. So this dip is further divided into two types, that is true dip and apparent dip. Divided into true dip and apparent dip. Now if I draw a line which is exactly 90 degrees or which is exactly perpendicular to the strike line, this line is called as the true dip. This line is called as true dip. Now any other angle less than or more than 90 degree, less than or more than 90 degree, is called as apparent dip. Now I will be drawing these many lines. These all lines are called as apparent dips. These are all are called as apparent dip. Understanding this concept of true dip and apparent dip is very essential in order to understand the dip and strike problems. Now the third most important part, you need to understand the relation between true dip and a strike line. So the relation between true dip and a strike line is they are perpendicular to each other. They are perpendicular to each other. This is a most important part to understand the meaning of, or to solve the dip and strike problems. To solve the dip and strike problems. Now let us see the first set of problems. Let us see the first set of problems where they are given us the amount and direction of a true dip, and we have to determine the amount of apparent dip in the given direction. So they are given true dip direction and amount, we have to find out, and also they are given true dip apparent dip amount, we have to find out the direction of the apparent dip. So let us solve first the problem number 1. Problem number 1 will solve. So problem number 1, or rather problem number 1.1 from the set 1, that in every set there are 2 to 3 problems, and among that we'll be solving 1 or 2 problems from each set. Remaining you have to solve by yourself. This is for the exercise purpose. So let us see for the first problem number 1. So grid bed dips at the rate of 1:6.5 in the direction due north 10 degrees east direction, and the amount of the true dip is given, that is north 10 degrees east, and the rate is 1:6.5. They asked us what will be the amount of apparent dip, in north 60 degrees east direction. Also state the strike direction. So first write down the given data. So first write down what all they are given. These are the basic 5 points which will be given in these problems. Among this they will give us 2 or 3 known. We have to find out another 2 or 3 unknowns. So for every problem this section of given part will be always repeated. So let us write down what they are given. They said they are given a true dip direction. So we mark the true dip direction as north 10 degrees east, and they mark the true dip amount as 1:6.5. Also they are given the apparent dip direction, that is north 60 degrees east. We have to find out the apparent dip amount. We have to calculate. Also we have to find out the strike direction. So before directly jumping into the understanding of the problem, let me give you a clear idea about what we'll be solving, or what is the basic funda behind this. So to solve this problem, we'll be solving by the graphical method, where you have to understand the concept of directions, that is north south east west line. North south east west line. So these are the directions, and we mark the intersection as point O. Anywhere, anyway, or all the directions whatever will be using with respect to the north, will be using with respect to north, all with respect to the south. We never measure the angles from west to north or west east to north or west to south or east to south. Let me repeat, we never measure any angles from west to north or east to north or west to south or east to south. We always measure all the angles from north to east, north to west, south to east, south to west. Okay, so this is a basic funda or basic understanding behind the problem. Let us see. Okay, so I have given the set 1, the meaning of set 1. Then let's see what are the given data. So they are given us the apparent dip direction, they are given apparent true dip direction, true dip amount is also been given. We have to find out apparent dip amount and strike direction. We'll be solving these problems with the graphical method. So first, on a plain sheet, let us draw north south east west line. This north south east west line should be exactly perpendicular to each other. If you make a mistake while drawing north south east west line, then your calculations may go wrong, and the intersection point of this north south east west line is marked with the point O. It's marked with the letter O. So first we have both the data for true dip, that is direction as well as amount. So we'll plot the north 10 degrees east direction and mark the 1 is to 6.5 as a amount. So I'll be measuring it from this side, from point O. I'll measure from point O. I'll draw north 10 degrees east line. I'll be drawing north 10 degrees east line. Then I'll write down what the meaning of this line is. I'll write down as true dip. This is the true dip and north 10 degrees east. Then I'll mark 1 is to 6.5 from the point O. I'll measure on this line. I'll measure 6.5 from point O and I'll mark it as my point. I'll name this point as point A. Name this point as point A. Then other things are half. We don't have the amount for the true dip, apparent dip, and we have only the direction. So let us first complete whatever comes with true dip. So I already told in the first slide of me that the relation between the true dip and a strike line is they are perpendicular to each other. Now what I'll do is I'll draw a perpendicular to the line OA at point A. To the line OA at point A. So this is, I'll mark first, I'll write down what is the amount is, then I'll plot this perpendicular line. I'll mark as a perpendicular line it is. Same way, parallelly, I'll transfer this strike line from point A till point, from the point A till point O. Okay, parallelly I'll transfer with the help of ruler scale. I'll write down this. These are my strike lines. These are my strike lines. So the duty with the true dip is over. Now let us plot the apparent dip direction as well. Let us plot the apparent dip direction as well. That is north 60 degrees east. I plotted. Now I'll extend this line. I'll extend this line such that it will cut my strike line, and wherever there is a point of intersection, that point I'll mark. I'll name it as B. I'll name it as B point. Now if I measure the distance between the point OB, I'll get apparent dip amount. I'll get apparent dip amount. And if I measure the angle, if I measure these angles from north to west as well as south to east, I'll get the strike direction as well. So strike has always two directions. Strike has always two directions. One is with respect to north and another is with respect to the south. So both these directions we have to write down. So here we got the apparent dip amount as well as we got the strike direction. So these two parts are over. These two parts are over. Now I'll write down the scale here, that is 1 is to 1 centimeter. I'll write down the results here as 1 is to 10. I measure this distance from O to B, that is 1 is to 10 or you may get 10.1, depend upon your accuracy of measurement. Then I write down the strike direction: north 77 degrees west, and another is south 77 degrees east. So here it completes your first problem. So whenever you draw without any marking, it will look like this. If you just follow the step-by-step procedure, whatever is shown in the video, you can easily solve this problem. You can easily solve this problem. We'll for better understanding, we'll solve one more problem from this set, that is problem number 1.3. That is problem number 1.3. The problem number 1.3 says that the gold vein has a true dip of 1 is to 4 in north 60 degrees west, and determine the amount of apparent dip in due north, north 80 west, and due west. Also state the strike direction. So in the previous problem they have given only one apparent dip direction. Here they have given three apparent dip direction. One is due north, north 80 west, and due west. So they have given three directions here which you have to plot. So that's the reason why I have taken uh, this one another problem from the same set. So here we have to understand the meaning of due north and due west. Whenever the word due comes and only one direction is given, the meaning of that is it's on the same line. The meaning of due north is on the north line itself. Meaning of due west is on the west line itself. If in case they give due east, then the meaning of that is it's in the east, it's on the east line. Same way, if it is given as due south, the meaning of that is on the south line itself. Okay, so we'll solve this problem. Again I'll write down whatever is given for better understanding. Then the procedure remains same. First we have to drop a north south east west line exactly perpendicular to each other. Then the intersection point is marked as O. Now I'll first plot again the true dip direction as well as amount, that is north 60 west. I'll be dropping it here in this direction from the point O. I'll drop north 60 west. I marked it as north 60 west. Now I'll write down first what it is. It is a true dip in direction of north 60 west. Then I'll measure 1 is to 1 1 is to 4. I'll measure 1 is to 4 from the point O. I'll measure 4 centimeters here. I'll mark the point. I'll name it as point A. Now after this I'll write down again how much is the amount, 1 is to 4. Then I'll mark the true dip. After marking a perpendicular line, I'll same line I'll transfer it at point O, and I'll name them as a strike lines. So with true dip the work is over. Now what I'll do, I'll mark north 60 degrees west. I'll mark apparent dip as north 60 degrees west, and wherever it is cutting a strike line, that point I'll name it as point B. Because they are given this north 80 west. So if I measure the distance OB, I'll get the apparent dip amount along north 80 west. Same way I'll measure it for due west. Wherever it is cutting, the strike line is cutting this west line, I'll be marking it as point C. If I measure the distance OC, I'll get the apparent dip amount due west. And same way for the north line, if I measure the distance OD, I'll get the apparent dip amount in the direction of due north. Okay. Now remain is the strike direction. Same way I'll measure these two angles. To get the strike direction as well. I'll write down the scale. I'll write down the results. So these are the results of this. Once you complete it, the diagram will look like this in your journal. Okay. Coming to next, so I have solved two problems from this set. Here onwards I'll be solving one problem from each set. So these are the at every problem big end of every set I have given already the answers for everything, so that you can uh, correlate, or you can, after solving, you can cross verify with those answers. Now, these are the answers for set number 1. Moving to set number 2, here they are given a details of apparent dip from which true dip has to be calculated. So determination of true dip from the apparent dip. So there are three problems here again. Okay, we'll be solving only one problem from this set. So the first, it says the coal seam, means a coal bed has an apparent dip of 1:7 due north 12 degrees east, and there is a similar outcrop. There is a similar outcrop who reads the dip of 1:5 due north 35 degrees west. Find out the amount and direction of a true dip. State the strike direction. So these are, let's see what are the given. They are given apparent dip direction. There are two apparent dips. There are two apparent dips. One is north 12 degrees east and another is north 35 degrees west. And for this, respectively, for north 12 degrees east, this is the amount, and for north 35 degrees west, this is the amount. From this, we have to find out true dip direction, true dip amount, as well as the strike direction. Let us solve this problem. The given data again repeated here. Same way, we'll be plotting first north, south, east, west line. We'll name them, and the point of intersection will be marked as point O. Then let us plot first the north 35 degrees west. North 35 degrees west. I'll write down, this is an apparent dip. This is written AD, north 35 degrees west. Then I'll measure 5 centimeter from the point O, 5 centimeter point from the O, and I'll mark this point as my point as A. Same way, I'll be drawing north 12 degrees east, drawing north 12 degrees east, and I'll write down first and then I'll mark the 1:7. So 7 centimeters from the point O. I'll name this point as point B. After this, whatever is given is over now. Now we have to calculate other details. Now what I'll do is I'll join this point A and B, join this point A and B, and parallelly I'll transfer this line at point O. With the help of roller scale, I will be transferring this point, this strike line to the point O. I'll mark them. These are my strike lines. Now, with this data, we have to identify what is the amount, true dip direction, as well as true dip amount. So we know there is uh, a relation between the true dip and the strike line, that they are perpendicular to each other. So what I'll do is I'll drop a perpendicular to this strike line. I'll drop a perpendicular to this strike line. This will be my perpendicular line, and wherever it is cutting, I'll be marking as perpendicular, and wherever it is cutting, I'll mark that point, because I had to find out the apparent dip amount as well. I have to find out the apparent dip amount as well, and I'll name this point as point C. Now, if I measure the distance OC, if I measure the distance OC, I'll get apparent dip amount, and if I measure this angle, from north to west, I'll get true dip direction as well. If I measure the distance OC, I'll get the true dip amount as well. And if I measure these two angles, I'll get strike direction as well. Okay, so we find it out true dip amount, we calculated true dip direction, and we identified the strike direction as well. Okay, so once you complete, this problem will look like this in your journal. Hope you understand how to solve the set number 2, because I'll be taking only one problem from this set. Then moving to third, before we move to this third set, these are the answers for the set number 2. Answer for the set number 2. Next, set number 3. So here they said the determination of apparent dip direction. Determination of apparent dip direction. We have to find out the apparent dip direction when true dip direction, true dip amount, and also the apparent dip amount has been given. So there are 3 given things, and we have to identify the remaining 2 matters, that is apparent dip direction, to find out the apparent dip direction, and we have to find out the strike direction as well. Let us see problem number 3.1. This is the problem number 3.1. This is the sediment strata has a true dip of 1:6.5 in the direction in due north 20 degrees west. In what direction will be the apparent dip? Will be the apparent dip when apparent dip amount is 1:13. The apparent dip amount is 1:13. Also state the strike direction. So what they are given? They are given apparent dip amount. We have to find out the apparent dip direction. Amount is 1:13. True dip direction is north 20 degrees west. True dip amount is 1:6.5. We have to find out the strike direction. Let's solve this problem. Set number 3, first problem. So these are the given data. So here the big problem is that we have apparent dip amount as 1:13, which cannot be fit in your paper. So what we'll be doing is, till now we were taking scale as 1 unit is equal to 1 centimeter. Here we'll change the scale as 1:2. We'll change the scale to 1:2. Like previous problem, we'll be again drawing north, south, east, west line. We'll mark the intersection as point O and we'll name it as north, south, east, west. Then we'll take a scale as 1:2 here. So here only the amounts will be divided. Only the amounts will be divided while the directions will remain as it is. The scale is applied only to the amounts. The scale will be applied only to the amounts. So first we'll draw again these 2 points because we have direction as well as amount. We have direction as well as amount. First we'll be drawing north 20 degrees west. I'll write down what is this. This is true dip TD north 20 degrees west. Then I'll mark the amount as 1:6.5. I mark the amount as 1:6.5. But here I have reduced the scale, so I have measured only 1:3.2, and same thing I have be writing here 1:3.2, and same thing I'll be writing it here. Now this is the true dip. This is the true dip. So we know better that the relation between true dip and strike line, they are perpendicular to each other. So what I'll do is I'll drop a perpendicular to the line OA, to the line OA at point A, to the line OA at point A. The same way I'll transfer this line to the point O as well. I'll name this, these are my strike lines. Now the duty with the true dip is over. Now we'll be left with only one thing, that is true dip amount. We don't know in which direction will be the amount, the apparent dip, in which direction is the apparent dip. So what we'll be doing is we'll take a compass. We'll measure 1:13, means with respect to scale it will be 1:7.5. It will be 1:7.5. We'll measure that 1:7.5 in a compass, and from the point O, we'll measure the lines on the strike line. We'll measure the strike line, wherever it cuts we'll mark that point and we'll name it as point B. Same way on the other side of the strike line, true dip, we'll be marking it in the same fashion. The reason behind this, that we don't know in which direction is the apparent dip, so we are taking on the both the sides. I'll mark this point as a C point. Then we'll join a line from C to O as well as B to O. Now there is no need to measure this distance because we already know the apparent dip amount, but we have to measure these angles with respect to north for the line OC and with respect to north to the line OB to get the apparent dip directions. So here we will be getting two direction. One is with respect to north and one with respect to north to the line OC and to the line OB. One is north to east and another will be north to west. Same way, this is our strike line. So we'll be measuring the strike direction as well. We'll be measuring the strike direction as well. So we'll get two apparent dip direction. One is north 39 degrees east and another is north 81 degrees west. And same way strike line, we have again two, north 69 degrees east, south 69 degrees west. Once you solve, you'll see this problem in this fashion. Yeah. Set it is set number 4. Here we have only two problems. Here what they are given is, till now we were measuring the strike direction. Here they are given a strike direction and apparent dip. They are given strike direction as well as they are given apparent dip. We have to find out the amount and direction of a true dip. So they are given strike direction and apparent dip, they are given. We have to find out amount and direction of the true dip. So let us see problem number 4.1. A soft shell bed in a hill cutting is striking north 40 degrees west with an apparent dip of 1:to 5.5 along south 20 degrees west. The apparent dip they are given, strike direction they are given. They are given strike direction as north 40 degrees west, apparent dip direction as south 20 west, and apparent dip amount as 1:to 1.5. Problem number 4.1 from the set number 4. So the given data is apparent dip direction, apparent dip amount is given, and strike direction is given. So unlike the previous problem, we'll be again drawing north, south, east, west line. Mark the point of intersection as point O, then north, south, east, west line we'll be drawing. Then, even though we have a data for apparent dip direction as well as amount, we'll first plot the strike direction, that is north 40 west. From the previous problem, we have seen that strike direction has always two directions. One is with respect to north and another will be with respect to south. They are opposite. So now here we have north 40 west, means it is obvious that we have another direction. We can extend this line towards the south direction as well with south 40 east. So I'll draw south 40 east as well. Now we got a straight line. Then we'll plot the apparent dip direction as well as amount. So that is south 20 degrees west. So we plotted south 20 degrees west. I'll write down this apparent dip south 20 degrees west and I'll mark the amount as 1:to 5.5 and I'll name that point as point A. Now the data is over, but we have a strike line. So what I'll do is, till now we were drawing a strike line at point A and we were transferring to point O. Here I'll be again doing it reversely. We already have a strike line at point O. The same strike line parallelly, with the help of roller scale or set square, I'll transfer it to the point A. Now we better know that this relation between the strike line and the apparent dip, relation between strike line and true dip is they are perpendicular to each other. So I'll drop a perpendicular to this line. I'll mark this point of intersection between a true dip and a strike line and name it as B. Then I'll measure the angle with respect to south. If I measure the angle, I'll get a true dip direction. And if I measure this distance OB, I'll get the true dip amount as well. So I got both the things with respect to this. If I solve it, the problem will look like this. Then these are the answers for the next problem also. Hope you understood and enjoyed this watching this video, and hope you will be solving this. If you want the soft copies of this all the problems, it is already there on my. You can visit this web page. I'll share the link of this in the description as well. Also, like, subscribe, and share for more such videos. Likewise, right now we have done the video for dip and stick problem. Same way, I'll be doing a video for other problems from the geology lab. Thank you.